Hello everyone, welcome all to Physics with Aeronautics. So in this video we'll discuss about some 2022 cpet physics question. So let's begin. So here is the first question of the session, that is Brewster's law in terms of refractive index can be expressed as, and the options are mu equal to sin ip, mu equal to cos ip, mu equal to tan ip, and mu equal to cot ip. And we all know that the answer is mu equal to tan ip. Then the electric field and magnetic field of an electromagnetic wave are given as E equal to 2I plus 3J and H equal to minus 3I plus 2J. So the magnitude of the Poynting vector will be, and here the options are 11, 8, 6 and 13. So here E is equal to 2I plus 3J and H equal to minus 3I plus 2J, which is given in the question, and we have to find out the Poynting vector. We know that the equation is E cross H. So by putting all this value and finding we can find out it as 13k. So the magnitude will be 13. So the answer is 13. Then the displacement current can be there in A, and the options are resistor, capacitor, inductor and solenoid, and here the answer will be capacitor. Then the energy stored in a magnetic field is, and the options are b square by 2 mu naught, b square by mu naught, b by 2 mu naught and b by mu naught, and this is the formula, and we all know that, and the answer is b square by 2 mu naught. Then sodium lamp is radiating power of 50 watt. The root mean square value of the electric field strength at a distance 3 meter from the lamp is, and the options are 1.29 volt per meter, 12.9 volt per meter, 18.2 volt per meter and 182 volt per meter. So here is the solution. You can see that in the question it has been given that sodium lamp is radiating power 50 watt. The root mean square value of electric field strength at distance 3 meter from the lamp is. The power is 50 watt and the radius of the lamp is 3 meter. And we all know that the intensity is equal to power by area. So we can write it as I equal to P by 4 pi r square. Again we know the another formula for intensity is half epsilon naught E naught square C. So by equating these two equations and putting all the value, we can find that E naught square is equal to 50 into 2 into 9 into 10 to the power 9 whole divided by 9 into 3 into 10 to the power 8. Again we know that E naught is equal to root 2 E RMS. So in the question it has been asking what is the root mean square value of electric field strength. So we have to find out E RMS. So by putting this value in this equation we can find out it as 12.90 volt per meter. So the answer is 12.9 volt per meter. Then a particle is executing forced oscillation with quality factor 12500. If the natural angular frequency associated with the forced oscillation is 12.5 second inverse, then the damping coefficient will be, and the options are 1.5 into 10 to the power minus 3, 2.5 into 10 to the power minus 3, 5 into 10 to the power minus 3, 7.5 into 10 to the power minus 3. So let's see. So in the question it has been given that quality factor is equal to 12500. We know the formula, that is omega naught by 2 beta. Again omega naught is given as 12.5 second inverse, that is the natural angular frequency. So by putting this value we can find that beta is coming out to be 1 by 2000. Again we know that beta is equal to b by 2m. So in the question it has been asking that find the value of this small b, but m is not given, so we can find the result. So let's jump to the next question, and this is the next question. Escape velocity is equal to for r is the radius of earth or any other planet for that matter, and g as acceleration due to gravity. And we all know that the escape velocity is represented as root over of 2gr. So the answer is root over of 2gr. Then a 2 kg mass attached to a spring of spring constant 8 Newton per meter will have the resonance when the frequency of the external source will be. And the options are 4 by pi hertz, 2 by pi hertz, 3 by pi hertz and 1 by pi hertz. So here is the solution. That is the mass is 2 kg attached to a spring of spring constant k is equal to 8 Newton per meter. So the angular frequency omega is equal to root over of k by m. So by putting these two value we can find out that omega is equal to 2. Again we know that the frequency is given us by omega by 2 pi. So by putting the value of omega in this equation we can find out it h 1 by pi hertz. Then two forces act at an angle of 120 degree. If the greater force is 80 Newton and the resultant is perpendicular to the smaller force is. And the options are 20 Newton, 40 Newton, 60 Newton and 80 Newton. So in the question it has been given that two forces act at an angle of 120 degree. If the greater force is 80 Newton and the resultant is perpendicular to the smaller force is. And take this F2 as greater force and F1 as smaller force. In the question it has been asking that sorry, this F1 is perpendicular to the resultant force. So again we can find out from here that this resultant force can be equated with F2 cos 30 degree. And resultant force is equal to F equal to root over of F1 square plus F2 square plus 2 F1 F2 cos 120 degree. When we equate it to the F2 cos 30 degree, that is 80 cos 30 degree, we can find out that F1 will be 40 Newton. So the answer is 40 Newton. Then a ball moving with a velocity of 5 meter per second impinges fixed plane at an angle of 45 degree and its direction after impact is equally inclined to the line of impact. If the coefficient of restitution is 0.5, the velocity of the ball after impact will be. And the options are 0.5 meter per second, 1.5 meter per second, 2.5 meter per second and 3.5 meter per second. So here is the ball and this is moving with the velocity of 5 meter per second. Impinges a fixed plane at an angle of 45 degree and its direction after impact is equally inclined to the line of impact. If the coefficient of restitution is 0.5, the velocity of the ball after impact will be. So from this diagram you can understand what is the case. So in the question it has been given that the coefficient of restitution E is equal to 0.5. We know that E is equal to minus B1 minus B2 by U1 minus U2. So by putting this value we can find out that V will be 2.5 meter per second. So I hope you all enjoyed this session. So for more videos please do like, share and subscribe. Thank you.